So, hello everyone, welcome to Physics Academy. This is our lecture number 4, I mean part 4 for Jest 2024 PIQ solutions. Okay, in this video lectures, I will discuss two part B 3 marks MCQ question paper. Okay, and in this question paper, we just discuss total 6 or 5 questions, because these sections have the questions and those questions have some lengthy solutions. Okay, that's why we take some two parts. We take two parts to complete the part B sections. Okay. Actually, I have upload solutions. I have uploaded solutions for whole Jest PIQ 2024 PIQ sessions with 6 videos. Okay, with 6 videos. So, by the way, I am Mithun Patro. I am a PhD scholar at NICER ECPS. I am actually working in exoplanetary atmosphere and exoplanetary formations. Okay, so let's start our lectures. So okay, this is question number 1. The energy spectrum for a system of spinless non-interacting fermions consists of n plus 1 non-degenerate energy level, and these energy levels have a energy 0, epsilon, 2 epsilon, 3 epsilon, and for nth state, for n plus 1 state have a energy n plus n epsilon. Okay, and let x equals to exponential minus epsilon upon kBt, where kb is the Boltzmann constant, t is the temperature, and for n identical fermions, there have n identical fermions in thermal equilibrium at temperature T. What is the average occupancy of highest energy level? Highest energy level means what is the highest occupancy? What is the highest occupancy for highest energy level? What is the highest occupancy? So we know here the energy particle distributions, fermions distributions for each energy states. So we know the fermions follow the Pauli exclusive principles. Pauli exclusive principle, and this principle restricts each energy level to have occupied at most one particles. That's why each state have only one fermions. Okay, now we calculate the partition functions. We know the formula of partition function, z equals to summation over e to the power minus beta epsilon I, where I 0 to n. Okay, that's why z equals to 1 plus e to the power minus beta epsilon plus e to the power minus 2 beta epsilon plus e to the power minus 3 beta epsilon and e to the power minus n beta epsilon, and where beta is the inverse temperature and it is represented 1 by kBt, and kb is the Boltzmann constant. We already know. And here given x equals to, actually in the questions given x equals to a to the power minus beta epsilon. Okay, let's substitute this value. So 1 plus x square plus x cube plus x to the power n. Okay, and if we solve this series, geometric series, then we get its have a solutions 1 minus x to the power n plus 1 upon 1 minus x for x not equals to 1. Okay, obviously for x not equals to 1. This is the solution. We already know this is class 12 mathematics. Okay, we use here class 12 mathematics. So basically we are calculating the partition functions of this given system. Now let's calculate the average occupancy of highest energy level. From the Fermi-Dirac principle, Fermi-Dirac theory, we have the Fermi-Dirac probability. We have the Fermi-Dirac probability formulas, that is equals to Fermi-Dirac probability for average number of particles. Actually we calculate the average number of particles for highest energy state. Okay, we calculate the average number, actually average energy state. For the formula of average number of particle for any state, that is have the a to the power minus ni e to the power minus beta epsilon I upon z. This is the average number of particles for ith state. Here average number of particle for nth state for e to the power minus beta epsilon n. Okay, e to the power minus beta epsilon n upon hz. So epsilon n is nothing but n epsilon. We are already know. So basically n expectations value of n capital N, that is equals to e to the power minus beta epsilon n upon z. So that is equals to e to the power minus beta epsilon whole to the power n upon z, and that is equals to x to the power capital N upon z. So average number of particle for nth state, that is equals to x to the power n upon capital Z. Okay, now substitute here the value of z, and z is equals to 1 minus x to the power n plus 1 upon 1 minus x, and let's substitute, then that is equals to x to the power n 1 minus x upon 1 minus x to the power n plus 1. So that is equals to x to the power n minus x to the power n plus 1 upon 1 minus x to the power n plus 1. This is the average number of particle as for highest energy state. So this option actually match with option A. That's why we use the analogy principle. And so that's the results actually match with option A. That's why for this question, highest the average occupancy of highest energy level, that is equals to x to the power n minus n plus 1 upon 1 minus x to the power n minus 1. So option A is the correct answer. So we use the principle, we use the mathematics here, how to calculate the average occupancy of highest energy level. Okay, next we go to the question number 2. That is very good questions. Okay, that is very good question. A two level quantum system has Hamiltonian h equals to h cut omega naught 0 1 1 0, and at t equals to 0 the system is defined as ket psi 0 ket equals to 1 0. What is the earliest time, that is t is basically greater than 0, which a measurement of sigma jet operator and which yield the value -1 with probability 1. Okay, so basically they ask if probability for sigma jet equals to -1, its eigenvalue -1 is equals to 1, then what is the value of time? What is the value of time? I mean, at what times we get that kind of probability? For sigma jet equals to -1, sigma jet equals to -1, it is basically this eigenvalue. Okay, so here the Hamiltonian is given. Here the Hamiltonian is given. At t equals to 0, the system in a state, this is a state defined already. Now the time evolutions of the state, psi 0 ket is governed by the Schrodinger equations, that is equals to psi of t equals to e to the power IIT upon h cut into psi 0 ket. This is the time evolutions. Okay, the basic. Now we calculate the eigenvalue and eigenfunctions of the given Hamiltonian, and this Hamiltonian is equals to h cut omega naught 0 1 1 0. This is the calculation methodology of eigenvalue, and the eigenvalue of this matrix is equals to ±1. So basically we use the principle of eigenvalue, rules of eigenvalue. Eigenvalue of this Hamiltonian is equals to plus minus h cut omega naught, and the corresponding eigenvector when eigenvalue is equals to this is for eigenvalue equals to plus h cut omega naught, and this is for eigenvalue minus h cat omega naught, minus h cat omega naught. The for eigenvalue h cat equals to h cat plus h cat omega naught, the eigenvector equals to plus kit 1 by root 2 1 1, and the eigenvector for eigenvalue minus h cat omega naught is equals to 1 by root 2 1 minus h for the Hamiltonian h cat omega naught 0 1 1 0. Okay, now the initial state psi ket psi 0 ket can be written as a superpositions of these two eigenvectors, plus ket and minus ket, and it can be represented at like that, obviously. Now the time evolutions of this eigenstate, now the time evolutions of this eigenstate is equals to 1 by root 2 e to the power I h cat omega naught into t upon h cat plus ket plus actually there, if we apply here 1 by root 2 e to the power minus e plus t upon h cat into plus ket plus 1 by root 2 e to the power minus e minus t upon h cat minus ket, and here we substitute the e plus and e minus, then we get it's actually 1 by root 2 e to the power minus h cat omega 0 t upon h cat plus ket plus 1 by root 2 e to the power I minus h cat omega 0 t upon h cat minus ket. So that is equals to 1 by root 2 e to the power minus I omega 0 t, and let's substitute this plus ket value 1 by root 2 1 1. Similarly here substitute the value of minus 1 ket value 1 by root 2 1 minus 1. So finally we get 1 by 2. Now 1 by root 2 1 by root 2 is multiply each others, and e to the power I omega 0 t multiplied with the Coulomb matrix 1 1, that is we get e to the power minus I omega naught t and e to the power minus I omega naught t. Similarly for another part 1 by 2 e to the power I omega naught t e to the power I omega naught t, we take common half, and this is a matrix additions, we just follow the matrix additions. So e to the power I omega naught t plus e to the power I omega naught t, similarly e to the power I omega naught t minus e to the power plus I omega naught t. So we know the cos x is equals to e to the power ix plus e to the power minus ix by 2, and sin x is equals to e to the power ix minus e to the power minus ix upon 2i. So basically from that part e to the power ix plus e to the power minus ix equals to 2 cos x, and from that part e to the power minus e to the power ix minus e to the power plus ix is equals to minus 2i sin x. Okay, e to the power minus 2i sin x. We just use this, and finally we get 1 by root 2 from this 1 by 2 cos omega t, 2 cos omega naught t minus 2i sin omega t, and 2 cancel each others. Okay, so finally we get cos omega naught t minus I sin omega naught t. This is the time evolutions of this psi 0 state. Okay, next we calculate the measurement of sigma z. Measurement of sigma z. So sigma z is equals to 1 0 0 minus 1. Okay, sigma z equals to 1 0 0 minus 1. Now the eigenvalue of sigma z is equals to plus 1 and minus 1. Okay, corresponding eigenstate for plus 1 for plus z is equals to 1 0, and for the eigenvalue is equals to minus 1 for minus ket z is equals to 0 1. Now probability of measurement for minus 1 I mean for this state is actually represented as p probability for minus 1 is actually represented as minus psi t scalar multiplications of two state. Actually this is the scalar multiplications of bra sigma bra minus z and the psi t cat. Okay, and its mod square. So and this is the multiplications. So 0 1 and cos omega naught t minus I sin omega naught t. After matrix multiplications we get minus I sin omega naught t. So this minus I sin omega naught 2 have a mod square, so that's equals to sin square omega naught t. So this is the probability value for sigma z equals to minus 1. This is the probability value or probability when sigma z equals to minus 1. Okay, and this probability value is equals to 1 actually. Okay, it's already mentioned in questions. This is the probability value is equals to plus 1. So sin square omega naught t equals to 1. So omega naught t equals to pi by 2 and 3 pi by 2. We take just one value. So omega naught equals to pi by 2. So t equals to pi upon 2 omega naught. So at that time we get the probability for sigma z equals to minus 1 is equals to 1. This is the solutions. So I think you understand the questions in better way. Okay, if we take a flow chart for these questions, okay, we make a flow chart. Okay, we make a flow chart to solve that kind of questions. We have Hamiltonian. Okay, we have Hamiltonian and initial state. Okay, we have Hamiltonian. First of all, we calculate its eigenvalue, then calculate eigenvector, and then psi 0 can be express superpositions of eigenvector, and then calculate the time evolutions, of psi 0. Okay, this is the first part. Next what can do? Next we do measurement of given operator. What calculate? We calculate eigenvalue. Measurement of operator means eigenvalue and eigenvector. Eigenvalue plus eigenvector. Then we calculate the probability. And we know the probability. Probability formula is new state, old state and its mod square. This is the approach to find out the probability, to find the probability for that kind of questions. Okay, so I think you understand the problem, how to deal this type of problems. Okay, next we go to the question number 3. This is very easy questions. The matrix A is given and its commute with the B matrix, the eigenvalue of B. That is very easy question, the eigenvalue of B. Let's calculate the trace of this A matrix. Trace of A is nothing but 2 plus 6 plus 6, that is equals to 14. And let's check which of the following have trace 14. So option A have trace 14, it's have a trace 16, it's have a trace 12, it's have a trace 7. So option match with option A. So that's why okay, that's why option A is the correct answer. This is very easy questions. Next we go to the question number 4. That is very important. A polynomial Cnx of degree n defined on the domain x equals to -1 to +1 satisfy the differential equation. Satisfy these differential equations. Okay, and the polynomial satisfy the orthogonality relations also, where n and m are not equal. Then what is the sigma x? You know, the differential equations is like that, and this differential equations, okay, matches the form of the CSIR polynomials of the first kind Tnx. This differential equations is actually matched with the CSIR polynomials of first kind, and this is equals to 1 minus x square d2tn upon dx square minus x d tn upon dx plus n square tn equals to 0. So for these differential equations, we have the orthogonality conditions for CSIR polynomial of first kind is equals to -1 to +1 cmx upon root under 1 minus x square dx equals to 0 for n not equals to n. So after comparing these two orthogonality conditions, we get the weight functions sigma x is equals to 1 upon 1 minus x square. So that is equals to 1 minus x square whole to the power minus 1. Please remember this. Remember this differential equations form and the orthogonality conditions for CSIR polynomials. Okay, so this is a very straightforward question. So option A is the correct answer. Next we go to question number 5. Consider a particle of mass m and non-zero angular momentum L subjected to a central force potential V of r equals to KLNR, where k is the positive constant. What is the radius r at which it can have a circular orbit, and will the circular orbit be stable or unstable? So what is the value of r, that's why this orbit will be circular. So here the central force potential is equals to V of r equals to KLNR, and we calculate the effective potential for this central potential equals to plus KLNR upon plus L square upon 2mr square, where L square upon 2mr square is the centrifugal potential. Okay, we have know the conditions of circular orbit. The first derivative of effective potential is equals to 0. This is the conditions of circular orbit. This is the conditions of circular orbit. Okay, okay, condition of circular orbit. Okay, so let's find out the derivative. D by dr equals to L into L square upon 2mr square plus KLNR, that is equals to minus L square upon mr cube plus k by r equals to 0, and that is equals to L square upon mr cube equals to kr, and 1 upon r square equals to km upon L square. So r square equals to L square upon km, so r equals to L upon km. So we get the value of R equals to L upon root under Km. Okay, next we check the stability of circular orbit. So for calculate the stability of circular orbit, we calculate the second order derivative of effective potential at R equals to capital R. Okay, second order derivative of effective potential at R equals to R. So d by dr equals to minus L square upon, this is the value of first derivative of effective potential. Okay, we already calculate, minus L square upon mr cube plus k by r. So that is equals to 3L square upon m r to the power 4 minus k by r square at r equals to capital R. So that is equals to 3 by L square upon m r to the power 4 minus k by r square. So 3 by L square, if we substitute here the value of capital R, also the value of capital R, after substituting we get 2k square m square upon L square, and that is the value of greater than 0. Okay, so as second derivative of effective potential is greater than 0, hence effective potential have local minima. Effective potential have local minima. If less than 0, have a local maxima. Hence if the effective potential have local minima, hence the circular orbit will be stable. Circular orbit will be stable. Okay, so in this section we have discussed the total 5 number of questions in details calculations. Okay, I will upload the PDF in my YouTube channels, PDF in my Facebook channel, Facebook page Q Physics Academy. So please follow my Facebook page for access this PDF also, and for more videos, more update about your examinations, please subscribe and like my channels, and share this video with your friend who are preparing these examinations, and I think they will beneficiary. They will get some benefit from my channels, because I will give you a details video solutions for each and every questions. You definitely know, right? So okay, and again thank you for watching this video. Okay, I will meet again another video lectures for the rest of the questions of part B3 marks question paper. I will complete the next part in next video. Okay, don't worry about that. Okay, so okay, thank you.